I am Dr. S. Venkateshan Jaykumar. I am very happy to introduce myself. I have both 16 years of teaching experience and 6 years of industrial experience as a research scientist. I teach chemistry for senior secondary level students and UG students, undergraduate students and postgraduate students, and I can handle research projects for both senior secondary and UG level and PG level students. Apart from that, I have rich experience in entrance exam coaching. I handle classes for IIT JEE level students and All India Pre-Medical Entrance Exam and JIPMER Entrance Exam, and apart from that, SAT Chemistry and GRE Chemistry papers I handle, and I am very comfortable to handle A level and O level. So I am official Olympiad chemistry trainer in a reputed international school. It is in Nilgiris as well as in Kodaikanal. Thank you. Good morning, dear students. Today we are going to discuss about substitution reactions. Substitution reactions, it's a class of organic reactions. Substitution reactions, it's of two types. So the general definition of substitution reaction is when an atom or group is substituted by another atom or group. So one atom substituted by another atom. The same we can reserve for functional group. One functional group can be replaced by another functional group. It is called substitution reaction. If the atom is a nucleophile or the group is nucleophile, then it is called a nucleophilic substitution reaction. The atom which exchange with other atom, if it is electrophile, then it is called electrophilic substitution reaction. So based on the nature of an atom, we can classify the substitution reaction into two types: electrophilic, nucleophilic. This is the general substitution reaction. Here X is substituted by Y and Y is replaced, Y is occupying the position. X is called leaving group, Y is attacking species, it is called reagent. So based on the nature of Y, the substitution reactions are two types. Okay. Now we are going to concentrate only about nucleophilic substitution reactions. Nucleophilic substitution reaction, a nucleophile is involved. All of you familiar about the nucleophile. What is nucleophile? Nucleophile may be negatively charged species or neutral atom or neutral group. So nucleophile, based on the nature of nucleophile and substrate, the substitution reactions are again two types. It is classified into two types, SN1 and SN2. So this is the general reaction of nucleophilic substitution reaction. You can clearly see Y minus, it is a nucleophile, it is negatively charged. This Y minus replaces the X. So Y occupies the position of X, then X is exit from the molecule, it is a leaving group. Okay. Now we are going to discuss the important terms involved in the nucleophilic substitution reaction. There are four important terms involved in the nucleophilic substitution reaction. Number 1, nucleophile. Number 2, leaving group. Number 3 and 4, substrate and solvent. Nucleophile. What is a nucleophile? Nucleophile is a negatively charged atom or group, or it may be neutral. It cannot be positive. So it is either negative or neutral. These are the examples for nucleophile: X minus, OH minus and OR minus, and sulfhydryl anion SH minus. It is derived from H2S. Then neutral nucleophile, the examples are ammonia, water, alcohol and ether. Here the lone pair electron plays a vital role. So the presence of lone pair which makes the group, which makes the molecule to act as a nucleophile. So lone pair plays a vital role. Then leaving group, a group which exit from the molecule by the attack of nucleophile. The group which leaves, that is called a leaving group. It is simply termed as LG. Nucleophile denoted by Nu. Whether Nu is negative or neutral, it is indicated as neutral lone pair, and here extra charges minus. Leaving group can be either X minus or triflate or mesylate. So these are the common leaving groups. Then substrate. Substrate can be aliphatic or aromatic. So if it is aliphatic substrate, then it is called aliphatic nucleophilic substitution reaction. If it is aromatic, aromatic nucleophilic substitution reaction. It is little rare. Aliphatic nucleophilic substitution reactions are very common. And solvent, then another important term involved in the nucleophilic substitution reaction is solvent. Excuse me. So now we are going to briefly discuss about what is SN1 and what is SN2. So we restrict our discussion today with aliphatic system. So SN1, it stands for substitution nucleophilic unimolecular. SN2 stands for substitution nucleophilic bimolecular. So it is a unimolecular process. This reaction is unimolecular, whereas this reaction is bimolecular. I will explain what is unimolecular, bimolecular. So for this substitution reaction to be carried out, we need only one molecule. So unimolecular, molecularity is 1. Here 2 molecules are necessary to carry out this reaction. It is important for this reaction to take place, 2 molecules are necessary, bimolecular. So molecularity 1, molecularity 2. The next point, it is a first order kinetics. It follows first order kinetics. That means the rate of the reaction, the rate of the nucleophilic substitution reaction SN1, the rate depends on only concentration of substrate. Here the rate depends on concentration of substrate as well as nucleophile. Here the rate of the reaction depends on both concentration of substrate and nucleophile. In some cases, if nucleophile is taken as excess, that is solvent itself act as a nucleophile, then it called a separate group of reaction called solvolysis. If solvent is excess, it is called solvolysis. If water excess, it is called hydrolysis. It is within the class of SN2, water excess, hydrolysis. The same we can apply for here also, solvolysis and hydrolysis. Now I am going to ask one question. Instead of water, if you take ammonia, liquid ammonia as a solvent, then how we can name this? How we can name this substitution reaction? Yes, tell me. Yes, correct. Ammonolysis. That is called ammonolysis. So solvolysis, hydrolysis and ammonolysis. So ammonolysis, ammonia is used as a nucleophile and it is used as a solvent. Okay. Then third point, SN1, it occurs by 2-step. So it is a 2-step mechanism. SN2, single step mechanism. It occurs by single step. In other words, we can say the whole process is a concerted process. Concerted means both bond making, bond breaking takes place simultaneously. That is why it is called a single concerted mechanism. And another important point, in the case of SN2, after the reaction, the structure of the molecule will change. So the starting substrate, the structure of starting material, substrate, can be changed during the process. So it can be reversed. So this inversion of structure is first identified by the scientist Walden. Therefore it is called Walden inversion. So here we end up with inversion of structure. It is called Walden inversion. Whereas in the case of SN1, no inversion. So here retention of structure as well as racemization takes place. So here planar carbonium ion is involved. So the reason behind this one, planar carbonium ion. In the case of SN2, no carbonium ion is involved. So no intermediate. Here it is, reaction is proceed through transition state. Here planar carbonium ion is involved. Because of planar carbonium ion, the nucleophile may attack either front side or back side. So both retention of configuration as well as inversion of configuration that ends up with racemic product, racemization. So these are the 4 important terms which differentiate, 4 important points which differentiate SN1 versus SN2. Now we are going to discuss individually what is SN1 and what is SN2. So this is the outline of 2 types of reaction. So now concentrate only SN1. What is SN1? Consider a bigger substrate, a bulky substrate, that is tertiary butyl bromide,